Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today we'll be talking to Dr. Tom DeSutter and Sam Croat about oil spill cleanup in North Dakota. What methods can be used to clean soils after an oil spill? What problems can face those trying to use these methods? What solutions might exist for those problems moving forward? Answers to all these and more coming right up. I'm your host, Abby Morrison. Let's talk about science. Hi, everyone. Welcome to the show today. We've got Sam and Tom with us. Sam is a soil scientist at Stealth Energy Group in Williston, North Dakota, in the heart of the North Dakota oil fields. She got her bachelor's at South Dakota State University, and she continued on to complete her master's at North Dakota State University under Tom. After graduation, she landed a job as a soil scientist with Stealth Energy Group and has been there for a year, focusing mainly on crude oil and saltwater spill cleanups. Tom is a professor of soil science at North Dakota State University in Fargo, North Dakota. He got his bachelor's at South Dakota State University, was a technician for Dr. J. Ham at Kansas State, and then did his PhD with Dr. Gary Przynski at Kansas State as well. After graduation, he worked as a postdoc for Dr. Tom Sauer at the then National Soil Tilth Laboratory, now the National Laboratory for Agriculture and the Environment, in Ames, Iowa. He has been at North Dakota State University since the fall of 2006. He would like to mention how fortunate he was to have Sam in his program. Sam and Tom also wanted to highlight Peter O'Brien, who is also instrumental in this research. Peter, as a PhD student with Tom, helped design the plots and oversee their construction, helped with harvesting, data analysis, and oversaw the preparation of this manuscript. Peter is currently doing a postdoc at the USDA ARS National Laboratory for Agriculture and the Environment. Welcome to the show, Sam and Tom. How are you doing today?
Excellent. Thank you very much.
We're doing well. Thanks for having us.
Glad to have you. So today we are kind of continuing the conversation on oil spills. Last episode, we were talking about the Deepwater Horizon oil spill. Now we are taking things onto the land and looking at land-based spills. Can you provide some background on oil spills on land in general? You know, how often do they happen? What are some of the negative effects that would, separate them out from sea spills, I guess? Anything about just this problem in general?
Yeah, so I guess if you go back 5-10 years ago when the oil boom in North Dakota had taken off, there was lots of infrastructure that was put in, a lot of oil was being extracted, and through that process, unfortunately, spills do occur, and the movement of that oil, whether it's through tanker, whether it's through pipeline, can cause at some point in time a spill may occur. And the difference between the ocean environment and the land environment is, of course, that the soils that are impacted on the land, whether they're agricultural rangeland or whether agricultural or cropland production or the wildlands, tend to be difficult to clean up in this semi-arid region. So the difficulties, of course, are the cleanup, how that cleanup occurs, and the timeline and the cost of those cleanups.
Yeah, and so we're kind of talking about the different ways that we can maybe address those cleanup issues that you mentioned. But before we get started, there's a few technical terms I wanted to separate out a little bit here. So the first two would maybe just be remediation and reclamation are two different terms. Can you explain the difference between those?
Yeah, so coming from the industry here and being in the oil field every day, remediation and reclamation do get used interchangeably, but there really is a difference between the two. So remediation would be taking the pollutant that's in the soil or in the water, wherever it is in that environment, removing it completely. So adding an amendment, which can be chemical, biological, and taking that pollutant out of there. Reclamation is more, that can include remediation under its umbrella. So remediation would be a step to get to a successful reclamation, which would be returning the land back to its natural state. So first we would go with addressing that spill or release that happened and remediating it. And then we would go on to making sure that that remediation went further to bring it back to natural state, such as, addressing the soil properties, seeding and revegetation of the soil there. So there is a difference between the two, but they do get used interchangeably here.
Sure. I will do my best to use the correct term moving forward. If I don't, I appreciate the grace in advance for that. So there's obviously a few different ways that you can go about the remediation process. So can you explain what are a few of the different methods that people use for this?
So some of the common methods are land farming, which would basically be digging up the contaminated soils, making furrows, if you will, maybe adding some nitrogen, and then letting the natural population of the bacteria help break down that hydrocarbon. So another method would be more of an in situ method where the spill is delineated, you know where it's at. They then inject what would be like an oxidizer to help break down the oil in situ. There's pros and cons to all methods. It just depends on what type of environment. Is the groundwater, is it close to the surface, and the timing at which these may occur.
Dig and haul is one of the most common that we see out in the western part of the state here, which really explains itself. So you excavate the material, you put it into a semi, and you bring it to a landfill, and there it may get land farmed, but if there's any sort of saltwater impact with that oil spill, there's really no land farming to relieve that. So it just gets put into a landfill, and that's our soil and our resource that's taken out of commission in the areas that we need it. So dig and haul, I would say, is one of the most common that we use out here, and that's kind of why we do the research that we do to find new methods, so we don't have to dig and haul everything and kind of just waste that soil that we have. That's so precious.
Yeah, I had no idea that dig and haul was even a thing, really, and that seems very just like short-sighted of just like, we'll just get rid of it. Just put it in a dump. Seems like that would obviously have some problems later down the line once you dig far enough. But that actually kind of leads us into the next couple of terms that I would like to discuss, which are really a couple of different techniques maybe that were tied in really closely with your study, one of which was kind of mixing different kinds of soils into the topsoil, which is just kind of that top layer, and then thermal desorption. So can you explain how those methods work?
So thermal desorption is a method where natural gas or propane is used to heat up soil to thereby volatilize organic compounds, which further get degraded into carbon dioxide. The ending soil product is considered environmentally safe and can be reused for either subsoil or for topsoil.
Right. One of the strategies they'll sometimes use is just kind of moving topsoil from one place to another. Is that correct?
Yeah, the topsoil situation in North Dakota is very unique. I mean, I'm from an area where we have a lot of topsoil that are, 1 or 2 feet deep of that dark layer on the top where we can grow plants very well. But here in the semi-arid region, we're limited on the topsoil we have to begin with. So when that becomes contaminated, and we do practice that dig and haul method, and we get rid of that topsoil, we have to find a new source. So we go and find new topsoil from somewhere else. That could be purchasing it from a landowner, or in this case, they can bring it from somewhere lower in the landscape where that topsoil has washed down just by, gravity and deposition. So you kind of just have to rob it from different areas. But, there's only so much here. And, you sometimes can't find it. So that's where we talk about the mixing of non-contaminated topsoil here with that thermal desorbed soil. So if we did a 50-50 mixture, we can jumpstart that burned soil, if you will, with the organic matter and the living organisms that's in that nice topsoil. And, we can compensate for what we lost that was contaminated.
So you were working on a very specific spill for this research project. Can you give a little background on that? Maybe what kind of oil it was, the scale, anything like that?
Yeah. So the spill that occurred was in 2013. It was due to a hole that had been created in a pipeline that was transporting Bakken crude, and so what ended up happening was, best guesstimate, about 20,000 barrels or about 860,000 gallons of oil, unfortunately, was released into the subsoil and topsoil in an agricultural field in northwest North Dakota. And how it was discovered, the landowner was harvesting his durum wheat, came across it, and at that point in time, they probably had, within 24 hours, probably 20 to 30 new people in their lives, whether they wanted to or not. It ended up being the largest terrestrial oil spill in the United States, and therefore it gathered a lot of attention. It was a very intensive process where the soil was all dug up, it was prepped, and ran through the thermal desorption unit. All in all, there was probably about 1.2 million tons of soil that was treated. On the backside, now you have soil a lot of it was mostly subsoil that was low in hydrocarbons, was no longer a threat to the environment, that would then be used to put back into the hole that it was dug out of.
To put it into perspective, so if you're looking at 20,000 barrels that was released on this land, for the listener to kind of compare that in their head, that would be about 30 of those rail cars that we see traveling up and down along the side of the highway on the rail tracks. Those tankers, the black ones typically, 30 of those is what was released into this farmer's field.
Wow, that is crazy. And it was all, as far as from like an aerial perspective, what is the diameter of the spill? Like, is it all just sinking into this farmer's field? Is it across miles and miles and miles? Like, how big across was this spill?
Yeah, so most of the spill was contained in an area of about 6 or 7 acres. But it got down to about 50 or 60 feet below the ground surface. And part of the reason is that this area has a glaciated landform. So there's sand and gravel, these lenses, and when the oil was under high pressure, because it was still being pumped through the pipeline, it found all those areas where it could travel very easily. And unfortunately, some of those areas where it could travel easily were 50, 60 feet below the ground surface. So it's a very impressive looking from the aerial view when you look at it when the site was very active. Unfortunately, it impacted about 77 acres in total, not all contaminated soil, but because they needed areas to stage, to drive, and they needed the safe slope, so the workers could remain safe all the time. It ended up covering about 77 acres in total.
Wow, that is wild. So I obviously want to focus on the science here, but I think this ties in well with why you're doing this research. And I know you and I have talked about this a little bit before, Tom, at the annual meeting. But so you're a farmer, you wake up one day, you find 30 tankers of oil in your field. I mean, what do they do? How do they respond to that? Obviously, if 77 acres of land are then, taken over for this cleanup process, how do they handle that obviously that's their livelihood that's being impacted, not only by the soil at the end, which is, another key facet of your research, but also just their day-to-day lives. What do they do?
So the responsible company would lease the land from the landowner and probably pay them compensation on lost crop for the years that they have taken over that site.
Yeah, but as far as, I think, as an initial, you're just very reactive. I mean, you don't know what to do. And that's where we got really lucky with the farmers that we worked with. They kind of took a step back and looked at the situation and made the best out of it. They allowed for research to go on at this site and, to bring in this technology and see how it works. We're very lucky with that.
Yeah, I know you got pretty close to them too. We'll talk about that a little bit later, but let's move on to your actual experiment then. So what were you hoping to test with this, and how did you go about it?
So one of the things that we had a question about was, and this was a larger question that the industry had about a thermal desorption. So there was always the idea that because you're heating the soil up so high that you're making the soil sterile, and it would no longer be good for anything, no longer for crop production, no longer for rangeland production. And that was something that we wanted to figure out, was that true or not? And the second thing was, we know that there is limited amount of topsoil available to us. I don't care where you are in the world. So we wanted to determine whether or not the thermal desorption soil, if blended with topsoil that was non-contaminated, would that be a viable replacement for natural non-contaminated topsoil? So we had a couple of objectives. One, to see if the thermal desorption stuff could ever be used again. And the second one was to figure out if, in fact, we are short on topsoil in any project, can blending be an option?
Sure. So you kind of had a few different kinds of soil combinations, I guess, that you were looking at. We'll just kind of list them out here to make things a little clearer. So you had, obviously, your control. You had straight thermal desorption soil, just straight contaminated soil, a mixture between your thermal desorption soil and just regular non-contaminated topsoil, and then topsoil with contaminated soil. Is that correct?
That's correct. Yep.
Perfect. So then once you had settled on your ratios of what you wanted mixed, had set up your plots, then what did you do next?
Yeah, so the mixtures that you mentioned were correct. And we also did each of those with an amendment of manure, just to add another layer of organics to that, if you will. So once we had all of our mixtures established, we created the plots out in the field. The first year that we planted a crop was in 2016, which was with hard red spring wheat. And then 2017, we did field peas. And 2018, we did the hard red spring wheat again. And we chose these based on the landowners' normal cropping systems that they do, and tried to incorporate it to their farming practices as best as we could. The main thing that we're looking at is yield, of course. I mean, that's what everyone wants to focus on. That's what's important to the farmer. That's what, keeps the money rolling in their operation. So we looked at yield and protein of the grain that we were harvesting. And then as far as the soil, we looked at a lot of different things, really. For my project specifically, we looked at soil organic carbon, which can kind of translate into soil organic matter. We looked at the stability of the soil, and we also looked at a little bit of the biology.
Hi, everyone. I hope you're enjoying the show. Interested in learning more? Sam and Tom's article, Crop Production on Heavily Disturbed Soils Following Crude Oil Remediation, published in Agronomy Journal, will be freely available for the next 2 weeks. You can find a link to it in our show notes. If you are a certified crop advisor or certified professional soil scientist, you can also take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Let's get back to the show. And what did you find?
So we'll start with the relative yield. So what we did with this data was that we made everything relative to our control. And our control was the non-contaminated topsoil. So what we would have had on this site before there was any sort of oil spill. So we have our topsoil and the soil treatments that had any sort of topsoil mixed in with them. So that burned soil, that was the 50-50 mix, and the contaminated soil that had the 50-50 mix, there were not any statistical differences compared to our normal topsoil, the regular topsoil. So that was a good sign for us. That kind of proves what we were just saying, that if you do jumpstart that burned soil or even the contaminated, if you give it a little bit of biology and chemistry, if you give it what it needs, it can kind of jumpstart and overcome the contamination and produce yields that we want to meet the county average. That was kind of our goal for our yield. So as far as soil organic carbon, mixing the topsoil with those other soils again increased the organic carbon, which was what we hypothesized. So we saw that. And as far as stability, we didn't really see any significant differences across any of our treatments. The overall stability of our soil was 85%, and an undisturbed prairie soil is about 90%. And these soils have been handled many times with the construction process of being thermally desorbed and creating our construction plots. So they are really doing very well for the circumstances that they've been in.
Sure. And I'm assuming you can verify this, that the contaminated didn't do as well as your control. But how did the full burned soil do on its own? And also, did the manure have any impact?
We want to make sure we keep in mind that the thermal desorbed soil was originally subsoil that was contaminated, and that the contaminated soil was subsoil, but it did not go through the thermal desorption unit. So basically, what we wanted to do was to look at, okay, if you have a situation where you have thermally desorbed soil that is subsoil, can that be used as topsoil? And we would hypothesize that no, it cannot be. For one, it does not have the organic properties that a thriving topsoil would have. Two, that the biology that was in there, if in fact there was, through the heating process would be destroyed. So the thermal desorbed soil is basically, you can think of it as it's really starting on the low end, and the odds of it producing the same amount of crop yield would be greatly diminished compared to a thriving topsoil. So what we found was that to be true, that the yields of the thermal desorption by itself and the yields of the contaminated soil were less than half of the non-contaminated topsoil. However, when you looked at it from the standpoint of adding the non-contaminated topsoil to the thermally desorbed soil or the contaminated, like Sam said, they actually were not statistically different. And in fact, they were only about 10 to 20% less than the non-contaminated topsoil. So that gives us hope in the fact that if in fact one is short on topsoil, which the first thing we always recommend is to use 100% topsoil. Now, in some cases, maybe that won't be the case. Therefore, blending might be an option that can be done. And there's certainly lots of research that's been done on what's called a technosol, which is a manufactured soil. So basically you have different organic products, you mix it with a mineral, and you create a new soil. so in essence, we're sort of making a technosol with our blends when we use the contaminated subsoil and the thermal desorption soil itself. So it's pretty exciting results, and we're hopeful that we can continue some of the research in our technosol sort of arena.
That's great. I think what's cool about this research is it's very gracious in that it's like, we understand that you can't always get 100%. And sometimes you just have to do what you can do with what you have. So I like that there's kind of this broad spectrum, from like contaminated subsoil, which is like, it's not going to be doing so hot, to kind of taking those steps of like, okay, well now we at least got the contamination out. Like, where are we there? And then, very, very similar to what you said earlier, is just making the best of a poor situation to really work your way up to eventually getting those fully healthy soils again. So that really appeals to me. I like that about your research. But what would you say are maybe some of the broader lessons learned or implications for the people who are working really hard to do their best to clean up these spills, or, obviously prevent them from happening in the first place. But when they do happen, clean them up as fast as they can, get those landowners back where they need to be. What are the big takeaways here?
Yeah, so I think that, to restate, the thermal desorption has been around for a long time, but it was the first time it had been used in North Dakota. And so that allowed the reclamation community, our folks from the Department of Environmental Quality, the landowners, to see the potential in this process. And one of the things that we learned about the thermal desorption is that the time of the remediation can be greatly reduced because it's an active process all the time. Now, I think the first thing that Nelson Environmental, or who are doing the thermal desorption, the number one thing that they recommend is that the soil is homogenized. So that's one of the things that we really came to appreciate was the amount of effort and time commitment, but also the knowledge that it takes to effectively reclaim a site using this technology. And we also learned that the product that comes out the back end, the thermal desorbed soil, can be reused. It's not completely useless. And I think that was part of the challenge of the industry as a whole was, what is this product? What is this, thermal desorbed soil? Can it ever be used for anything again? And I think we've, through our research, through the scientific method, showed that yes, it can be, but having a jump start with the organic matter, with the microbial communities of a non-contaminated topsoil, makes a huge difference in its ability to serve as a crop growth medium.
And what are areas of future research for this?
From a research standpoint, we learned a lot from the thermal desorption process itself. That process won't be used for all oil spills. And so it gets back to what Sam was talking about with the blending of soil, the sourcing of topsoil, making sure that when that soil is put back, that it's not compacted. That's a challenge for the industry. In a research world, if you did small plots, you could put the topsoil back on in buckets. You could walk on it with a feathered slippers so you don't compact it. But the reality is the machinery that Sam and her colleagues operate is much larger than that. They're scrapers, they're dump trucks, and so soil compaction becomes a major challenge for the industry. The sourcing of topsoil is a challenge. Landowners want their own topsoil if they can. The risk of purchasing topsoil is you bring in different weed seeds. You bring in soils of different texture, which causes an issue with water flow, the compaction. Anything else, Sam?
No, I think you're covering it well.
I've got 3 questions left for you. So the first one would be, if people want to learn more about these topics, whether it's the spills themselves, the research, these techniques, what are maybe like 1 or 2 key resources that you would send listeners to? We'll have plenty of other resources in the show notes as well, so nothing will be missed.
Right. So we're fortunate to have now Dr. Peter O'Brien, who was a PhD student on this project. He is a prolific writer. He was a phenomenal student and a wonderful friend. He wrote a couple of review of literatures on the topic of thermal desorption. And I would point to those, one of them being Evaluation of Soil Function Following Remediation of Petroleum Hydrocarbons, a review of current remediation strategies. And the second one would be Thermal Remediation Alters Soil Properties, a review. And both of these reviews cover the reclamation and the remediation of oil-contaminated soils quite well. And they'll give the reader a great overview of the processes.
Sure. Sam, did you have any resources you wanted to share?
This is a pretty broad topic, and there's a lot of different avenues we could go down as far as questions. And I think Tom and I are both open to answering questions. So regarding soil in general, anything like that, as far as, reclamation in the oil and gas industry. So contacting us, directly is fine too. I'm happy to answer any questions. This is a very interesting project and research, and I think we both enjoy speaking about it. So that would be my recommendation.
Great. Yeah, we will include links to those papers from Peter, as well as your contact information in the show notes if people want to reach out. Second question for you would be, if people want to take kind of the next step and get involved in this research or issue in general, what are a couple ways that they can do that?
So nobody wants a spill. So if a landowner or if a citizen of the state discovers a spill, the first thing to do is report it. Once it's reported, then the method of why it's being contaminated, why that release is occurring, that can be stopped. And that is very, very critical, is to make sure that there's a timely stop, if it's a source of that contamination, so it doesn't spread to a larger area than it already has.
How does one go about reporting an oil spill? I would just be like, the police? I don't know who I would call.
So as far as reporting a spill, there's always a number on like the nearest well pad or drilling rig nearby. There's going to be an emergency contact number. So if you find something, drive to the nearest one of those, contact that number, and somebody is going to listen. They will they'll get you in the right direction of, maybe it's not even the right company, but they'll get you in the right direction and get you the right contact info for that.
The citizens of the state, if they detect a spill, if they see a spill, the best thing they can do is call 1-800-472-2121. And this is our state radio 24-hour hotline. Once that number has been called, that activates the North Dakota Department of Environmental Quality to broadcast that spill with the landowner or with the responsible company, and therefore hopefully a resolution of the source of that spill can be stopped. And at that point, the Department of Environmental Quality is involved. They will send out an inspector, and a report at that point will be filed.
And I think this goes for whatever state you're in, there's going to be a similar system. This isn't just unique to North Dakota. So in addition to, reporting spills and knowing how to report them, as far as getting, involved or getting more information, the Soil Science Society of America or the American Society of Mining and Reclamation, they have websites, and you can become a member of these, where they'll send you, monthly magazines with articles such that Peter O'Brien has written, that you can just kind of familiarize yourself with the new reclamation techniques that are out there or what we're researching. So if they just want a little taste of what reclamation is and what goes on, that's a good way too.
Perfect. That's another great couple of resources. We'll include those in the show notes as well. Final question for you. What is one fun fact that listeners would not know about you if all they had was your research?
Fun fact about me would be that I learned how to make some of the best pie through this project. Patty, who was the one of the landowner, she's a wizard at making pies, and she made pies quite often for the crew that was working up at the site. There was ended up being a very strong relationship between the landowners, us, the Department of Environmental Quality, the oil company, and the folks doing the remediation. So it was a wonderful blend. It was a good model. It was a good model of how all these different groups can work together for a common goal. And through that process, I learned how to make pie.
Yeah, I think Tom and I, we have the same fun facts and hobbies in this situation. So Steve and Patty Jensen have become very, very close to me as well. And I guess my fun fact would be that I do like to hunt and fish. And Steve Jensen actually is to thank and to give credit for me harvesting my first North Dakota deer since I moved here a year ago. So.
Oh, wow.
Yeah.
Well, those are extremely fun facts. What a blessing and joy to meet such great folks that were just really happy to work with you on this project. Thank you to both of you for being on the show, for the research you're doing, and thank you to all the people out there who are working hard to stop spills, clean them up, do all the work that needs to be done to have a healthy world for us to live in. So thanks for being on the show.
Thank you very much for having us.
Thank you.
Thank you for listening to Field Lab Earth. You'll find a link to today's paper and other resources for this episode in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on Apple Podcasts or anywhere else you find your podcasts if you like our show. This podcast is a joint production of the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by authors are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.